Now we are coming on the second video. Now today's second video. There are certain results we have going to prove, and in that few result you can use as a properties also. I'll tell you that will be the property. Just like this will be a property for us. You can use it directly. This can be used as a property. Other we will solve it or just prove it. We can use the properties and we can solve these questions. Uh, First, I'll take these two properties. One by one, we'll prove it. We have to prove A minus B is A intersection B dash. We have to prove this. So I start with this. Let X belongs to A minus B. What does it mean? X is an element of A and X is not an element of B. I told in the previous lecture, this is the condition I told you. And if it is there, then I should say X belongs to A. And if X is not in B, it should be in B complement. And now end is here, X belongs to A and X belongs to B dash. What does it mean? X belongs to A intersection B dash. So whatever elements of A minus B are here. So we should say A minus B will be a subset of A intersection B dash. This is equation 1. Now I start with the second case. Let X belongs to A intersection B dash. Then what does it mean? X belongs to A and X belongs to B dash. Right or no? X is an element of A and X belongs to B dash. Or I should say X belongs to A and X does not belongs to B dash. B, sorry. As it is not in B dash, so it will not be in B. And if it is in A, not in B, so where I should say X belongs to A minus B. Or I should say A intersection B dash is coming subset of A minus B. This is condition 2. And from equation 1 and 2, what you can say now, hence A minus B is coming as A intersection B dash. So A minus B is coming A intersection B dash. This part you can do yourself now. B minus A is B intersection A dash. So these are the two properties now you should keep in mind, and you can use this in questions also. Now coming on further question number 3rd I am taking. In third, there are two options. One will take X belongs to but as we have done so many properties, you can make these questions simpler by using the properties. For example, this is the question we have. In which property we have done? What that property visible to you? That is A minus B we have done. You know the formula for A minus B. Just like here it is. A minus B is A intersection B dash. So I start with left hand side. This I am doing directly by using the property. It will come A intersection B dash intersection B. This is the left hand side. A intersection B dash intersection B. Then you have done one property more. What that property was? You have done associative property. What the associative property says, that this bracket can change. So A intersection B dash intersection B. And now if I say B dash and B dash says what? Now this is the thing you should keep in mind. If this is set B dash means this. One element is from here, another is from here. So what is the intersection? You should remember this also as a property. What that property says, A intersection A dash will be phi. And if I say A union A dash, that will be universal. These are the two properties more you should note now. A and A dash. By the way, this is given as A. Then A and this is A dash. If you take union of the two, it will become universal. A and A dash, if you take intersection, common will be nothing there, phi. So here in this case, B dash intersection B. So in B and B dash, nothing is common. So we should say it is A intersection phi. And in identity property, I told A intersection phi. In A and phi, what is common? Phi only, because the smaller set is phi. So I should say A intersection phi is also phi. This also you can remember. A intersection phi will be phi. A union phi will be A. Whenever union, we get the bigger set. Whenever intersection, we'll get the smaller set. Same way if I say A intersection universal. Intersection always a smaller set. A and universal. So it is coming A. A union universal. Which is bigger one? This is universal. So these are all properties you should remember now. These should strike in your mind and then you can solve the question easily. So this is a very simple question I told you. A minus B intersection B. So A intersection B dash intersection B. Then associative property. Then B dash intersection B is phi. A intersection phi is what? Phi only. So we will say hence it is right hand side. So we got this. Okay. One more. This is the question we have done. Now coming on property. This question number 4. What it says: if A is a subset of B, if and only if B dash is a subset of B dash. This if and only if. This is the symbol for if and only if. That means if this is there, this should hold. This is there, this should hold. Okay, so I start with this. Let B have. I grant this condition. A is a subset of B. We are granting this. Second time I'll grant this, I'll break this. I'm taking first this and then I'll bring this. Then X is an element of B dash. I've started with this. I have to show that B dash is a subset of A dash, means whatever element of B dash must be present in A dash. So I've taken X as an element of B dash. What does it mean? X does not belongs to B. X is not a member of B. If it is not a member of B, what I have done? A is a subset of B. All the elements of A are in B. If X is not a member of B, it cannot be a member of A also. So this implies X does not belongs to A. And if X does not belongs to A, where it should go? It should be in A dash. So what I have got here? X is an element of B dash and now I got X is an element of A dash. All the elements of B dash has gone in A dash. So what does it mean? B dash will be a subset of A dash. Hence. Now I'll take the other case. Other case means I'll start with this. Let we have B dash is a subset of A dash. And then I start with this. X is an element of A because we have to show all the elements of A are in B. So X is an element of A. If X is an element of A, what I should say? X does not belongs to A dash. X is in A, that means it cannot be in A complement. If it is not in A complement, means it cannot be in B complement. So this implies X does not belongs to B complement. And if X is not in B complement, where it should be? It should be in B. And that means A is coming as a subset of. Hence proved. This is property number 4 or question number 4 we have completed. Now I'll come on this part. Fifth property or fifth question or sixth question. One by one I'll take. First I'll take fifth question. What it says. And one more thing, these questions you will be going to get only when you practice it. Union, intersection, complement, these properties should be clear in your mind and then you can apply them. Now I'm starting with A minus B union B minus A. We have to prove this. So to prove this, now coming on this problem we were doing. So X belongs to A minus B union B minus A. What does it mean? X belongs to A minus B or X belongs to B minus A. Then we have done this property also. X belongs to A and X does not belongs to B, or X belongs to B and X does not belongs to B. Right or no? X is an element of B and this is OR, this is AND. So this you should keep in mind. This way we are just going continuously. So first step will be, I told that this is the condition, then this is the condition, then this is the condition, this is separate here. Now we'll continue. Yes, after this we will have X belongs to A and an OR. Now I'll interchange. So it will be OR X does not belongs to B, and is here X belongs to B or X does not belongs to A. So and OR are simply interchanged. Yes, I think the previous and or interchanging, that will make more difficult. So I'll just take the other way. This part is okay. Now I'll come on the next part. This is single will take capital X or, and this is here and. So we are going for distributive property. What first distributive property says? X belongs to A and X does not belongs to B. This is here, or X belongs to B. This is one part. Okay, this or this, then and remain here, then this whole or this. X belongs to A and X does not belongs to B, or X does not belongs to B. After getting this result, I will go on distributive again. Or is here and is here. So I go on distributive again. So it says X belongs to A or X belongs to B and remain here. X belongs to B or X does not belongs to B. This is distributive on this. And second part, X belongs to A, does not belongs to A, or X belongs to A and is here. X does not belongs to A or X does not belongs to B. This is the distributive property. Now this has no meaning. X is a member of B or not a member of B. It means it cannot be possible, or we should say it is gone to universal. Universal and this will be the quantity. So there is these two terms we can't write same. So here we will say in next step we will remove this. So X belongs to A or X belongs to B. And here in this case this part is removed. Left is X does not belongs to A or X does not belongs to B. Then it says X belongs to A union B, and here what you should say, X is an element of not in A, not in B. That means it is either not in A or not in B. If X is either not in A, not in B, means either it is not in A, not in B, means where it should be. It should not be in the intersection. So we will say X does not belongs to A intersection B. Now it is X belongs to A and X does not belongs to this. So what does it mean? X belongs to A union B minus A intersection B. Hence proved. This is showing that this will be a subset of this. Same way we take the reverse and we will get the other. And next we'll take in the next video because it's going exceeding the time. Thank you.